We might be live now, even though it hasn't actually fired up.
It says we're live.
Yeah, good. So I'm going to try to cut this a little bit better too. Now it's live, and yep, there I am saying we might be live even though I don't see it.
Yep.
So I'm going to mute that, follow chat, see if anyone's chatting. But otherwise.
Okay, let's kick off. All right, so welcome to Data Science Discussions. My name's Jahan. I'll be hosting the session. Maybe I'm a guest host. I would say I'm this is a bit of a sojourn for me, but an enjoyable one nonetheless. So I'm a former data scientist and data analyst. I'm now a product manager. And we're here with Craig Savage. I'll let you introduce yourself.
I'm Craig Savage. I'm an analytics consultant with my own company named Doc Savage Solutions, which is behind me, due to the wonders of green screens and AI technology to replace a green sheet with whatever we like.
Mm-hmm. Very, very nice. All right, so today I want to introduce a topic. A very common complaint of data scientists and data analysts is that you are basically, challenged at this level when you want to try and get in the door and get a data scientist job. We've all been there. Where you ask those really, really mathy questions, extremely difficult coding questions, and then you get to work, and it turns out, you basically could do this job with maybe high school level maths at best, and some very, very basic SQL, or maybe just Excel. So we're going to be talking a little bit about that. We're going to first just talk about our respective journeys in our careers in data science and analytics. From there, we're going to look at what data science interviews look like. And for those out there that are looking for work, we're hoping this might be a useful little section for you. And then also just discussion around what this means. And for more, this might be more useful for hiring managers. If you're hiring data scientists, there might be some unintended consequences for hiring based on extremely high ability to do mathematics and very, very difficult programming challenges when the job is actually quite different. So I'd like to kick it off with you, Craig. Could you just walk us through your career, what you've done so far?
Yeah, so calling it one career is kind of interesting in my opinion, because originally I wanted to be a university professor. And so I went and got an advanced degree in applied mathematics. And I had this problem that when I entered university, I thought I wanted to be an astrophysicist and got an internship doing astrophysics, which was mostly programming, to be honest, because I was doing a lot of theoretical work on obscure topics. And it's very difficult in astrophysics to get the measurements you want. You can't actually go out and find a bunch of pulsars, orbiting stars, and just grab measurements from them. But in a sense, I'd kind of consider that data science, because you're making simulations, you're comparing it with observations, as we discussed last time, predicted versus actual. How does it all look?
I think they're the most legitimate data scientists out there, like astrophysicists, when it comes to level of respect. I don't think anything tops that. Yeah.
So from there, I hit quantum mechanics, and that was kind of a wall for me, because that was just math. It stopped being physics anymore, in my opinion, and became just math, and I hated it. So I went to engineering. And engineering was the opposite. Engineering, there wasn't enough math. There was just a lot of, and then you approximate this with a line, and close enough. And so I then worked in defense.
Somewhere in the middle, I'm sure.
Yeah, I worked in defense, and that's where I kind of became a data scientist. All the regression theory I learned was on the job, and it was really, it's funny because on the job is where I got the right blend of theory and practice for my taste. So a lot of this idea talking about interviews that you need to know all these things. No, I didn't know any of the stuff that I work on day to day now. I learned it on the job. So from there, I then went through a bit of a midlife crisis, quarter life crisis, third life crisis. What's the, I don't know what the right fraction is. Moved to Australia and did biomedical engineering. And then didn't like the cycle of academic grant writing and moved into banking. And that's that's when the term data scientist really started to kick in. And previously
what year was that when you moved into banking?
That was 2012.
Okay, yes, perfect time.
Yeah, so previously it was data mining or engineering work or programming or academia paper writing.
I think that's just when you had that meme of the data scientist, and it said like with the Venn diagram of the programming, business context, and maths.
Yeah, or the modern data scientist, where you have the nice person standing, and the 4 pillars of programming, math and stats, business acumen, and data visualization, communication, I think.
Communication, yeah. I remember those going around. They were exciting at first, and after a while I realized it was basically the same recycled content again and again and again. So how did you find then when you moved to the banking, what happened after that? So now we're at your actual data science journey. We've moved past the kind of the prologue.
Yeah, so from finance / banking into consulting, and how banking and biomedical engineering are kind of the same but different. Different in that the amount of data you get from working with a major bank is huge, whereas in biomedical engineering you might get very detailed data but patient by patient. So you might have 3 or 4 patients, but you get 60 hertz data collected for weeks. So you get a lot of information about very few people, versus banking, you get a little bit of information about millions of people, millions of mortgages, right? Or the same mortgage over 10 years. And so it's big, but the data is like different. It's deep or wide depending on which way you organize it, which is which. But they're both regulated. So you're somewhat limited as to what algorithms you can throw at these problems.
Yeah. And you worked across several organizations, I understand. What kind of drove you then to your most recent endeavor? You moved into more consulting, your own consultancy.
So I was with a small consultancy, which was then purchased by a large consultancy. And the culture of the small consultancy was we were all experts, and you could give any kind of credit risk model build project to any of us, and we would do a wonderful job. And we were all autonomous, and there was a central function that went out and got the work and gave it to us as casuals. And when the large organization acquired us, I was one of the few that remained casual. So I got a lot less work because they gave it to their full-time staff first, which is fair enough. So I never really intended to go independent. But there came a point when if I wanted work, I'd have to find it myself. And if I'm going to find the work myself anyway, I'd rather do it on my terms rather than their terms.
That makes sense. And so I guess I'm just kind of looking back at your career so far, talking to maybe yourself as the wide-eyed, budding astrophysicist or budding biomedical engineer, biomedical scientist. What are the things that you've learned about data science that you wish you knew back then?
So when I was an engineer in Tucson in defense, there was an older guy that would go around really preaching that, okay, you have all these fancy algorithms that you use for all these things, and that's not what's going to break you. What's going to break you is you're using 10-year-old technology and it doesn't behave the way you think it does. Or, someone makes a slight change somewhere and it has unintended consequences that ripple down. And I kind of understood what he was saying, but I didn't really believe him. And I wish I had paid more attention to him.
Yeah. And so when you're talking about like 10-year-old technology, you're talking about like the way the data is actually collected and the kind of information systems underlying everything, or are you talking about something else?
I'm being, because it was defense, I'm being a little intentionally vague. But
okay.
if you, like your cars, right?
Extrapolating out the idea from the context.
Yeah, like let's say you have a car that was built 20 years ago. Well, what type of chip does the computer run? Is it running a Pentium? If the Pentium goes bad, what do? It's not like you can go out and get another one. There are no more Pentiums, right? Well, let's go back 30 years. You have a 286 running in your system. Well, you don't get a 286 anymore. And you think, well, okay, I'll just pull out the 286 and put in the new one. Well, now the power requirements are different. Where's the power coming from?
Yeah.
Okay, put in a bigger battery. Okay, you put in a bigger battery. Well, that means that it has more weight. And if it's a fixed volume system, you put in a bigger battery, well, something else has to go. What goes?
Yeah. Interesting point. I think, the integrity of the system is something that you care more and more about as you advance in your career in data science, because you understand that this is where all the data is generated, and all those fancy algorithms are not going to save you from reality. Which is, if you have data that's bad, or stuff that's not updating, or records that are just duplicating all over the place, your number is going to be off. And we've all been burnt, I think. So I might quickly jump into then my background quickly, and then afterwards we can dive into the data science interviews. So my background is I was not as industriously, I was probably neither as industrious nor as quantitatively gifted as you were. I was a musician and an ESL teacher, and I, after realizing that I was, basically at the top of my field by being at the bottom of it, because it was a completely flat field, it was basically a dead-end job, very interesting, fun one. But after a couple of years of that, I realized, there's only so long I want to be earning essentially minimum wage. I went back to uni and decided to study psychology because of the areas that interested me. Psychology was basically at the top. And then from there, I realized there was a huge stats component, which is where kind of psychologists and social scientists in general kind of hoodwink you, especially in Australia. There's a lot of statistics required, and a lot of people hate it. And I don't think I was necessarily not one of those people. I didn't really love the statistics until I started really learning it and get my head around it, and understanding that you can answer questions that are quite meaningful about the universe with data. Who would have thought? I blame the education system here for leading us to believe that's always the area of the humanities, like it's all philosophy, whereas some of these things are actually quite empirical. So I really like the tool set I got from psychology, and from there I started looking for jobs in the area of where I could essentially apply statistics and that training I had. Obviously, statistical training in psychology is kind of statistics light, really. I mean, you do learn linear regression, logistic regression, all that stuff. But you don't learn it in the same way that someone doing a master's in applied statistics would learn it at. So I was definitely at a disadvantage compared to other people with much stronger quant background. So when I moved into market research, eventually I got a job there, and then I was up against PhDs in econometrics. And all of a sudden, my knowledge of some statistics was kind of laid bare, and I realized I had to really upskill. So I did a master's of business analytics at the same time while working. After a couple of years in market research, I moved into a loyalty program provider where I was looking at loyalty data. So rather than surveys coming in from 1,000 or 10,000 people, I'm looking now at data being generated by hundreds of thousands of people with millions of records. And then from there, I moved into I went to Quantium, where I was working on Woolworths data typically, which is then probably billions, I think, of transactions. So it gets bigger and bigger.
And so did you also feel like you learned on the job?
Oh, I definitely.
Because you mentioned feeling a bit overwhelmed next to some of your peers.
Definitely. I definitely felt like I was always kind of, because I never really quite learned one area and stayed there long enough to really master it before I moved on. So market research, that's all about understanding your sampling frame and knowing how to weight a data set to make it representative. There's a lot of focus on more the statistics side of it. So, how do you build a linear regression that's stable? How do you handle multicollinearity? That kind of thing. And then when I moved into, say, Quantium, there was much more of a focus on machine learning, but really it was the data wrangling side of it. That was the biggest thing. If you could get that stuff done efficiently, you had time to then think about the cool stuff. But a lot of the time it was, okay, we need to build an ETL pipeline to pull these numbers in, and it's going to be big, and it's going to require you to have an eye for detail. That was the kind of skill set I needed there. Whereas my understanding of variance inflated factor, or my ability, my understanding of the differences between ridge regression and lasso, no one really cared. Let's be honest. Whereas really? At Cohort, it's probably more okay.
Even at Quantium,
people would care in the context, but it was more like at Quantium, people know this stuff really well anyway. And to be honest, okay, let me back up and be honest about Quantium. At Quantium, there are some people there that really knew this stuff inside out, and they'd be the ones that be shining. I had my skill set, which is more around understanding kind of how to connect the dots and understanding what something means. So if the question is is this a problem or not? We have this problem with the model, the numbers are quite small, but is it actually going to be, meaningful? I was quite good at that kind of thing. But if someone was this optimize, how can we best optimize this, this function, that very much wasn't where I would excel. Like people would be much better at feature engineering and like coming up with solutions where like you look at their kind of their ROC, AUC kind of stuff. Like you look at all the metrics and they'd just be killing me. They'd be crushing me, and their program would be so much better. So I had like there's the things I was good at, and then the things I was not so good at Quantium. And my knowledge of theoretical statistics and stuff was not on par with the best people there. Whereas at like AMIA, for example, was before, I probably definitely did stand out, at least in Australia, because it was a small company and not at the level of Quantium. So I definitely don't want to cast aspersions on Quantium and make it sound like I was some kind of quant genius, and they weren't. Quite the opposite. But yeah, I ended up moving into product management though. And the reason for that is product management is ultimately more where my natural interest would be. So what I mean by that is when we're looking at a model and trying to understand, what's the best way for us to build this model, I don't care about the model as much as I care about its application. So if it's about learning something and using, like, say, the beta coefficients to understand driver analysis, I care about then what the implications are. So taking it a step further and not saying 40% of the variance is explained by this, but this is something that we think you can move the needle on because historically it's something that does fluctuate, and we think that there is, a chance this is causal, whereas this thing over here feels more like it's due to a change in cohort, for example, and therefore isn't something you can act on. So that's kind of making it meaningful. Or if it's about actually implementing something in production from a user perspective, what does this mean? I was less interested in, I want to be the person to write the code and give all the detailed briefing notes, but more, how can we make sure that this solves a problem, which is exactly what a product manager is meant to be doing. So,
right. So what skill would you call that? And if I'm prepping for that skill, how would I, what degree would I get that says I have that ability? Or what could I do as a job seeker to say, hey, I don't want to be the person writing the code. I don't want to be the person deploying the code, but I can help explain the code to you, or I can help you with the application of a model once it's built, or I can, right? Because it doesn't sound quite like data translator, but even data translator, I don't know what skill that would be. In terms of a piece of paper to hold up and say, I am a data animal.
I would say it's a data translator in terms of, insofar as there ever could be such a thing. And I'd say that the skills you have to have is partly the same skills as everyone else. You need to be able to code. You need to be able to essentially build it yourself. But on a team with other people who are better at that skill than you are, you might write a little bit less code than they do and spend a little bit more time, for example, maybe putting presentations together where you break down the concepts in a way that people can understand it. In terms of what you need, in terms of qualifications and experience to be able to showcase that skill set, I'd say if you have a mix of degrees that seem really pragmatic and then also quite theoretical, like let's say an MBA plus, a maths degree, or a marketing major plus, let's say statistics, that would probably signal that you might have those skills. But I mean, honestly speaking, there's no guarantee. It's not, they don't teach it to you. So I'd say it's really, psychology, there is a focus on that. There's a real focus on, they're saying things about the world. They're saying that, for example, this, like the fact that they move their hands slightly more on the right-hand side when you show the stimulus is indicative of this psychological phenomenon. So therefore, we're saying that these people who exhibit this behavior are blah. Like, so that there's a big focus on that in psychology. But I wouldn't say that that's something that you could really showcase to employees and people get it, because no one knows that's the thing. So I'd say if you want to say that you have these skills, the easiest thing to do is just to show that you have them by making sure that your resume contains stories that speak to that. And then in job interviews, making sure that you always speak to the broader context and what you're trying to achieve, and then what the algorithm delivered rather than what it was. So what did it do for the business? What did it do for end users? How did you craft that story? How did you bring people along that journey? That's kind of how I'd frame that, because it's a very niche thing, and it's not something that most people think they need until they're sitting in a room and they don't understand what the hell the data analysts are saying. And often it's because they just haven't been, they just don't know enough about basic statistics. And it's not like the data scientists can't describe it. But when there's such a massive gap, sometimes it's hard.
Yeah, I've made kind of my consulting living on building all of this end to end, primarily using Shiny. I think you came to one of my presentations.
Yeah,
The idea is, okay, I made the model. Now the model gives me a prediction. I use that prediction, and with that prediction, I do this. And because I'm forecasting an increase in click rate, well, now I have a new click rate. Right, I can now start to say I'm going to sell 1,000 more widgets. But then if I say I'm going to need 1,000 more, I'm going to sell 1,000 more widgets. Well, now I need to go back into the supply chain and be like, hey, I think I'm going to need 1,000 more widgets. How quickly can you turn that around? Because I don't want to be in one of these situations where you go live and it's as successful as you want, but then you can't fill orders. And then it becomes a little bit of a gamble, if you will, because my big fancy model says our click rate's going up. And if our click rate goes up and our conversion rate stays about the same, then we're going to need, like, this is what all the impacts are. And if I've targeted wrong, and in fact our click rate goes down, or if, yes, I get more clicks, but there are people that aren't really interested. Some of the games people play with ads, like putting a red box with an X in the upper right hand corner so it looks like a close. Well, people will click it. It's not helping you sell, but people will click it. So
I think it's
it's building that end to end. And for me, a lot of that was in my mechanical engineering or design. I'm going to turn on a bit more light here. Excuse me. Let's see if and so for me, that's where it came from, was this whole design theory about you need to build the entire product. You can't just build a little piece of it. You need to think of all those interconnections, going back to what the guy in defense was saying, that you may think you're just going to change this one little thing, but then it cascades through, and you need to be ready for that.
Oh, 100%. I really think that like that's talk here was great, just because so much of what we do, it's maybe a Zeppelin notebook or whatever it might be, and or Jupyter notebook, sorry, Zeppelin, Scala.
I know what you meant.
Exactly. No, it's just bringing me back fever dreams. I'm not a fan of Scala, but not saying anything wrong with it. I much prefer doing Python.
I have no idea. I have no idea what Scala is.
No, it's the language of Spark. Anyway, I'll stop bagging it and getting to go on my nodal tangents. But no, I think what was really good about that is it just, the way you solve that problem of, there's so much time between putting the model together, getting predictions. You inherently understood that, like, cycle time and bottlenecks are such an enemy of getting things done quickly. And what you really did was process engineering,
right,
with the solution of yours, where you could come up with a model, present to a manager, and then go through 5 iterations in like that, as many seconds more or less, right, rather than adding a week or 2 every time, which you see happening all the time. So you clearly understand the game you're playing, which is good.
But again, process engineering, I mean, there's a little bit of that in my MBA, maybe operations research. But again, I don't know from an interviewing point of view, other than the fact that I've done it, I don't know how I would go to an interview to say I do process engineering.
So let's get into that then. So maybe let's walk through some of your experiences with data science interviews, maybe a bit of the good, the bad, and the ugly.
Yeah. So before it was called data science, as I said, it was a lot more programming and math. So interviewing for defense, I was using what I considered to be some high-end algorithms, which was basically expressing things in Fourier series. But I was able to do it kind of on the fly and say, this is how it works. This is how, a Fourier transform works. This is how a wavelet transform works. Wavelets and fuzzy logic were 2 of my big hoorays back in the day. I don't know if people still use them anymore.
Actually, I think everything's a GBM now, but
yeah, or deep learning neural network, auto ML. Just
boost.
throw it into auto ML and whatever comes out wins, right?
Yeah. But yeah, go on. I find that impressive. But yeah, how'd that go?
And so from there, I got into a research division. And my job was basically, here's some paper by some academics, break it or prove that it works. Pick one.
Yeah.
Because a lot of the assumptions of, all errors are IID with a normal distribution of known variance or known covariance if you get matrix, and everything is nice and linear, and well, the world doesn't quite work that way.
No.
Or, you know, assume that your true distribution looks like this, and then you have some policy, and now we can see who we approve and decline in the case of like credit risk. And then you can see, you know, if people would have repaid had you given them the loan, and so it's unfair because this person that you denied would have repaid. Well, unless you give them the loan, you don't know that. It's unobservable. You don't know if they would have repaid or not. But if you make certain assumptions, then you can say, well, they would have. And it's like, well, then why is their credit score so low? Right? Like it's yeah. So it went from my first interviews where, hey, I can do a lot of math, and then it became, hey, I can write a lot of MATLAB code. I haven't written MATLAB code in 10 years. But even with the MATLAB code, a lot of what I was doing was automation. Because you'd run a test, you'd get a bunch of data, and you'd need to be able to reproduce the results and have an explanation as to what happened, and give plots and errors and animations and everything else. And I was doing all of that in MATLAB.
And how has it changed then in the last couple of years from then, if at all?
Well, now it's all in R, and the application is different, but I still have that process engineering mindset of I need to be able to trace through, once I have this model, what am I going to do with it? What is the input going to look like? Are the inputs productionizable? Yeah.
Either
So,
way.
you know, it's easy enough for me to go out to the ABS and get economic data and run with it. But unless you're going to build a data pipeline to the ABS to get the data, maybe that doesn't work so well.
Yeah, absolutely. I think a lot of people don't understand that that, you know, gbm.fit bit of code is nowhere near as important as the, you know, you pulling the data from the original source, going through and, you know, cleaning it and making sure it's in the right kind of structure and format. And that's 80 to 90% of the job. And then the last 10% is the stuff that everyone goes, hey, I think I could do that. Well, I'm interested in this career. And you're like, oh, okay. It is a small portion of the job, even though it's the payoff. It's the thing that you do it for. I'd say, well, at least it was for me. Interesting. To maybe compare and contrast our experiences, I think the job interviews I've been to have definitely been really varied. I think you can really understand a company. Like I went to one, like you can understand a company from how they do their interviewing. I think where they stare and fire is a lot. Yeah. So I typically, you know, will look for a grueling interview. It's not particularly difficult in general. I'll think that the company's not very ambitious. I went to one where they kind of, and also like there's difficult, and then there's also, are they looking for stuff that is clearly irrelevant as well? That's another sign they might be incompetent, where they just want you to show off in some way, shape, or form, and they don't quite know what they want. I went to interviews before where I think they just wanted me to kind of talk to the data, and it was very, they were looking for fairly simple analytics, but they're looking for very nice salesmanship of the numbers, which to me suggested there were more sales and fluff than actual substance. And I think I was right. And then there are other places where it just got super, super technical, to the point where I kind of say, look, I don't think you're optimizing for the right thing here. I think like I applied for a job and I was flown over to the States for this interview. I get there and I'm sleep deprived, and they're asking me questions like, essentially I have to be able to calculate a binomial distribution on a whiteboard without completely analytically. And I was told ahead that I'd need to do something like this, but the fact that I had to do it on the fly while being sleep deprived, and the fact that I'd never ever do that, no data scientist would ever do that analytically on a whiteboard. We have R, we have Python, we have all kinds of things you could do even in Excel, and you'd be fine. This just seemed a bit weird. So I think I did well, I think the business context side, but they wanted me to be super, super technical. And I'm 100% sure that a lot of those technical skills, while nice to haves, are definitely not must haves. And they might be, like I said, they might be optimizing for the wrong thing, getting very technical minds, and then ultimately failing just to live up to the promise afterwards and not stimulating them enough with interesting challenges.
Yeah, it's one of my beliefs that any interview question that you can Google the answer is a bad interview question. Because I'll just Google it. If I need to rederive the binomial distribution. There's a Wikipedia page on the binomial distribution. I'll go look it up. Like, what's the problem? Like, I can do this. Some of the best interviews I've had have been personal, where if I say, yeah, I use the logistic distribution, it's okay, well, tell me about it. What problems did you have? It's not, what are the main assumptions that go into using ordinary least squares?
Oh God,
right?
yes.
It's this problem you had. What problems did you have? How did you pick your variables? And if I say, oh, I just ran stepwise and hit go and whatever came back worked, that's not as good of an answer as, well, I ran stepwise and looked at it and talked to the experts, and I did some more feature engineering based on that and included variables that they preferred rather than the ones the algorithm picked. And, I engaged with stakeholders and I did all these things. As I get older and kind of move up, my interviews become a lot less technical and a lot more, well, what have you done? What Absolutely. Will you do for us? And it's not, I can do a binomial distribution on a whiteboard or invert a binary tree. And it's more, I get timelines down for building a model from months to days.
I think they start to really, at least the good places as they get more mature. Because I don't know if a lot of that, part of that might be your seniority increasing over time. A part of that might be also just the industry maturing over time and realizing that you're more than just a technical monkey that, writes code, but you actually, have a brain and are motivated to do good work and will make an effort to make stuff happen. And it's your ability to make stuff happen as well as do the technical work that is valuable. It's the two of those together, not just the way that you write the code on its own.
But as you said, you can learn a lot from the organization or, at a more micro level, the people. But if the person interviewing you expects you to be just a coder in a machine, and they give you time and money and you produce code and that's all that happens, that's like, go get AutoML, go get Data Robot. Like, you don't need a person to do these things.
Totally. Yeah, I think one of my most enjoyable experiences with Interview of Quantium, and I won't get into the details of it, but it was very much focused around what I'd done in the past, and they asked technical questions to understand how I went about it technically, and that was really, really just, I think, satisfying and edifying. Like, I could see that they understood what I was talking about, which was good, because I didn't want to work at a place where people were just analytically kind of illiterate. And I have heard of places where, like, even senior analytics people don't get very fundamental basic analytics concepts. Like, I don't want to work at a place where people just think of GBM as like this thing that does stuff. Like, you should at least understand it's recursive trees. You don't need to know how to solve the optimization formula, but problem, but you should understand that part of it, etc. So that was really good. I think they did a really good job of understanding what did I do analytically, but then also how did I bring it all together and make sure I get the results that I wanted, or how would I communicate something as well, all that kind of stuff. Like, can I take the technical hat off and go into a meeting with middle management or leadership or whoever it might be, and make sure they just understand it and trust it, rather than here's everything I did, which can often be a thing. So I want to jump into then, what do you think the way that companies interview people? So we talked a little bit about kind of people who just push you with really technical stuff, too much focus on coding and less of the focus on what do you actually do? What are the results you actually bring to the table? Where have you seen this kind of go wrong, where people have been hired that maybe either weren't the best or were just not a good fit? Do you have any experience of that?
Well, so recently I applied for a job and there was a coding challenge. And I go to do the coding challenge and there's no option to debug. You could pick which language you were using. And I picked R. And then I got to the last question and it said, hey, write some Java code. I was like, I don't know Java. Now what? There's no person. So I think my code was print error. Candidate does not claim to know Java. that was my submission, right? So
I would have given you the job based on that alone, just for the SAS, but
yeah. So things like that happen where it, to me, felt like they were interviewing me to be a developer, or that what I consider a data scientist and what they consider a data scientist weren't the same thing. As a consultant, I've been given some different titles that to me meant nothing. And sometimes it's not even internally consistent, where my contract would say one thing, but on the briefing note to management, I was listed, my title was something else.
Oh,
So
wow.
a lot of these things aren't even internally consistent as to what they are. And then you get the games about, well, if you're an analyst, your pay range is here, but you're currently, right at the top, and we're going to give you a pay rise, but we're not going to give you a promotion. So you're not going to be an analyst. You're going to be a data scientist now. Poof, there. Now you're in a different band. Or you're not going to be an analyst. You're going to be a analytics consultant or a senior analyst, or we're just going to throw some other words at you, because then that'll gets us through our HR system.
What's your take on all the different terminology? Like, we have one word for carpenter, and we've managed to keep it for a long time, since Jesus was around.
Well, sort of, because there's carpenters and woodworkers and machine shops, and
like, that is true. That is true.
And 3D printing now, if you want to get into that,
well,
like virtual woodwork.
But obviously, trust a good data analyst to find all the edge cases. But that aside, though, the number of data analyst, data scientist, analytics consultant, analytics specialist. I see data ninja and stuff on occasion, which I will.
Yeah. So I mean, we're all data people here, right? There will be type 1 and type 2 errors. If you're looking for a data scientist job, there will be jobs that are labeled data scientists that don't match what you think it should be, and there will be jobs of some other title. You're like, oh yeah, I'm doing data science now. Like, it's a classification. It's got errors. And if you make it multidimensional, it becomes multi-dimensional errors. Maybe you can put up the confusion matrix of true job title, as if any one of us has the authority to give a definitive definition of what a data scientist is.
And speaking of exactly that definitive definition, there was a bit of hoo-ha going on around that a couple of years ago. Do you think that conversation has any validity, or is it just people being silly?
I think it's an interesting discussion, but it also kind of amuses me that data scientists, some of the purists, the real data scientists, you need to have, dozens of variables at least, unless you're classifying someone as a data scientist, in which case 3 or 4 in a binary tree works. Like if you say, like, the only way to do this is with dozens of variables and XGBoost, and decision trees just aren't enough, but your classification as to whether or not someone's a data scientist is a decision tree, well, you've just disproven yourself a little bit. So I get a little amused when people do that.
But I guess it's more I'm thinking, but is there anything to that? Is there, because yes, it does seem, I mean, the dozens of variables, the need to be using specific algorithms, like obviously, because there's an arbitrariness to saying, okay, there's 8 variables and I use linear regression. Then I found 11 variables and use XGBoost, and now I'm a data scientist. Is there anything actually there behind that conversation at all? Or it sounds like you're saying it's just silliness, and I'd be inclined to agree with you. But when you get right down to the...
Yeah, it's like, at the end of the day, if I call myself a data scientist, I earn 20% more. So I'm going to call myself a data scientist. I don't actually consider myself a real data scientist, but for me, being a data scientist is, if I go back to those 4 pillars, in my opinion, the data scientist is pushing more into the communication and business acumen side. But LinkedIn seems to think it's pushing more into the programming and statistics side. So
that is true.
You can have the same infographic with 4, but how you weight them is up for grabs.
And it seems like both definitions touch on a more senior and competent data analyst, but in your case, it's more that you're better able to interface with the business, whereas they see it as you're better able to do the advanced coding and machine learning challenges.
Yeah, but
areas of expertise.
A lot of the coding, the tools are so good, like, it's deceptive.
I entirely agree. That's why I personally think it's just different. All we're really talking about is different levels of competency as a data analyst. If you have no training as a data analyst and you can use Tableau, then it's just early days. Call yourself a junior data scientist. data analyst, who cares? It's clear what you can do doesn't change because of the title. If you can get a few extra dollars, power to you. But then after a while, yeah, you might learn some SQL, you might understand, central limit theorem and significance testing and a few other things. And then after a few years, all of a sudden, you actually can code really well and you have a really good working knowledge of linear regression, XGBoost, all that stuff. At that point, are you suddenly a data scientist? Probably not. You've probably already been for a little while. Yeah. I don't think it's like an ugly duckling suddenly becoming a swan after like a certain number of years or time in the field.
I giggle because the ugly duckling theorem is one of my counterexamples for, just run things by the numbers. Your business understanding isn't important, just run it by the numbers. Like, I'm a firm believer that if it were possible to run businesses by the numbers, control theory would have replaced us all a long time ago.
Oh yes, that's true.
So,
and speaking of,
but for you, like, as you transitioned away from the data scientist at Quantium and into more of a management role, like, okay, you have a different title now. Do you feel like you have this brand new skill set coming from your undergrad days as a musician to being a data scientist to being a product manager? Like, do you feel like you gained these new skills and you shifted gears and now you're a product manager, or did you kind of stumble into it? Like, how did that transition happen? Are you now the swan that you stopped being the ugly duckling data scientist and now you're the swan product manager?
I'd say, like, there's definitely a sense that I'm playing to my strengths now, that's for sure. And I think now I can use I think the data science background and data analytics background is super useful. It's really the basics. It's just understanding, like, I can obviously code and write SQL queries however I need, or I can do a data analysis in R, which means I'm not as dependent on the data analysts for every little bit of like analytics I need to get done. And also I'm just able to talk to them a lot better. So when I get them to do stuff, the work they give me tends to be of a lot higher standard because I'll find problems. Like, a lot of people in the past would just give them a brief and maybe they didn't push back enough, or maybe it was just, this has been done in the past and no one was questioning it, but people looking at, like, say, like metrics, like finding an average time for something to be done, like average task completion time, for example. I'd never use a metric like that just because the distribution is going to be exponential. If you're a data analyst, you know that. It's the time between two events. So, I'd try and just find a cutoff point and say, okay, we need to get a percentage of these experiences within that band. So if the goal is for it to happen in less than 5 or less than 10 seconds, let's then look at what percentage of these interactions happen in that time frame, and then set some targets based on that, rather than saying we want average time of 15 or 30 seconds, because you'll be very far away from the middle point or the central tendency, not like there actually is any on a curve like that. So just stuff like that, or engagement, just come out with metrics, understanding what the amount of work needed for metrics. So Quantium, that's such a big thing. So if you're looking at something like, say, I release a new feature, I don't care how many people click on it. I care about what proportion click on it, which means I care about the top number and I care about the bottom number. And the denominators where things get hard. Like, how do you define people that are part of your addressable cohort? Over what time period? It depends on how often people engage in this behavior. So I'm thinking about all those things immediately, and then you're thinking about things that will come in and confound your data and mess it up. So once you kind of think things through like that, rather than saying, oh, we had 300 people click on it, I can say I've got an engagement rate of 15%, which might be terrible. So whereas the other person might say, oh, 300 clicks, and they're like, is that good? Is it bad? Well, it's better than 299, I guess.
Yeah, not as good as 301.
Yeah, exactly. So I think that's where it's been really useful. But otherwise, though, it's a very different area. A lot of the time, my data analyst skills aren't so relevant, but then maybe more abstractly, being a product manager, I was saying before on the call, just we were chatting, I'm a very detail-oriented product manager because data analytics is all that detail. If you don't know where the numbers actually come from, all the changes, the transformations they go through, and then what the final results, are coming from, you'll miss the big picture. You won't see when you're like bleeding your target variable into your dependent variables, etc. You won't see the big picture of how you're actually cooking the books analytically. And the same thing, that attention to detail has certainly served me well as a product manager.
Okay, but again, from an interview point of view, to say you have attention to detail is one thing.
Mm-hmm.
It's the running joke that you say you have attention to detail and then you have spelling errors in your cover letter. It's like, oops. But this idea of these are all the pieces and this is how I have worked through all the pieces, and it's kind of odd because in my opinion some of the best interviews are when you say, and then there was this mistake and this is how I found it and this is how I fixed it. This is what the savings were. And it's not, and then my mean squared error went from 0.1 to 0.01. Well, I don't know what that means, right? But then it increased our customer engagement, then that increased our click rate, then that increased our visibility into the importance of this feature. Or it gave us insight that people were looking for something else. And so maybe our next feature should be this other thing that everyone's searching for and we don't really have a solution, for instance, which is a lot more than, and then I ran XGBoost.
Yeah. I kind of feel like that's like, describing a nice romantic evening out and just kind of bring it down to just one perfunctory thing to just say that you had a good time and show off your status as a man. It's kind of like, who cares? We care about we want. Actually, no, it's a very, very bad example.
I was about to say, I don't know where you're going with this, mate. I might need to cut you off here.
No, I was thinking about movies rather than real life, and just the crude stories from, say, like those like coming of age films where like people talk in a very, very pejorative way. And I was just thinking more like you're kind of they're missing the soul of everything. They're clearly missing the point. Is the example I was trying to give there. But yes, before you cut me off and when you jump to the ad break. But no, I think you're very right. Like I think job interviews for anyone out there applying for work right now, I think storytelling is something that just often doesn't get taught enough, because people there's cues and stuff and like frameworks to help you tell a story in a job interview. Like that's what the STAR method is. It's scenario, task, action, result.
So can you give an example, with and without that?
Well, my point, I can, but my point is that before I get into that, is just really, that's just telling you story structure. That's just telling you, like, don't forget, if you're writing a book and you forget the S, it's going to be a really confusing book. You'll be kind of wondering why these people are like, why is Frodo trying to get to Mordor? I don't understand. Or you skip the action. It's just like, okay, that's great. I'm happy to throw the ring down into the fire, but I don't quite understand how that happened. And the result, it's like, okay, that's great, but like, what? I don't get where this all went. So it's just making sure that you don't forget how to tell a good story. So I'd say like the advice here is not so much learn the STAR method, but obviously do. But the better advice beyond what people already know is like, think about how the story really gives them a good sense of how you operate and the things you do and the things that you think about when you're working and your motivations and the unique contributions you make. So for example, if you want stakeholder management, show your knowledge of your organization and the people you chose to engage and when and how, and making sure that, the decisions you made, they can kind of see from your perspective. I've worked in recruitment and I see people kind of fumble through answers, which is most people. Most people kind of fumble. Some people completely fumble and fall flat. Some people just get through. But then every now and again, you meet people who are actual superstars that just can walk you through so much to the point where you feel like you're there with them. And it's weird because that's just pure storytelling ability. It's not saying they're necessarily better than other people, but the fact that you kind of understand how they see their company, how they see their job, how much more kind of forethought they have. They can really see, they're really thinking ahead. You just know immediately that if they were to join this company, they'd be in and, they'd be out running and showing so much initiative and really sense making very actively. So your request was to use an example of it.
To use it and to not use it. So I'm interviewing you for this data science role, and I want you to tell me about linear regression.
Okay. So I can tell you about a story with linear regression. Let's just say I'll do it without this. So yeah, it's a good example because here you haven't actually prompted for a situation.
Right, exactly.
So, yeah, so I might make the mistake, and it wouldn't necessarily be a mistake. Like it could be they just want to know technically, and I say, okay, linear regression is where you take typically the ordinary least squares approach to solving it as an optimization problem. You want to find the coefficients that give you a line or a hyperplane through a multi-dimensional space where you minimize the distance from the points to the plane. And at this point, if they're mathematically inclined, they might pick some errors in what I've just said, although they might be happy with that. But it's not really saying much about my higher ability. So maybe an alternative way, and you could ask a clarifying question to find out if they want to know about your mathiness or if they actually want to know about how you've worked with linear regression. Then doing that again, I could say, okay, linear regression is a way that you can predict a continuous variable from various other inputs. It's a statistical approach, meaning that unlike machine learning approaches where you're less interested in how the actual machinery works. Here you want to make sure it's done the right way, because otherwise you might get bad estimates and bad coefficients and thus a bad model. So I want to tell you a story about how I, in context, had to come up with a model and get stakeholders across it. And then I had pushback and I had to deal with that, and I had to kind of balance off the interpretability and usefulness of the model versus the actual mathematical kind of robustness of it. And I could easily give stories from market research where there was cases where the best model was where we have one variable as a predictor rather than another. And if you take one out, the other one will jump in because they're highly multicollinear. So it was just about understanding in that case. So beyond just how do you optimize for the best adjusted R squared and the lowest RMSE, whatever it might be, it's also interpretability and understanding where the covariance is. Like if you were to do a PCA regression, what would be the clusters of different factors that load on the variable of interest, right? And so then when you're talking to stakeholders, they might be saying, okay, I think satisfaction is driven by that, not that. And you say, okay, well, they're both in the model, but one's quite weak and the other's quite strong. Looking at the BIFs, I can see they're highly collinear. So you could say that, broadly speaking, this area of satisfaction really drives satisfaction here. So the story isn't so much that it's exactly this thing, but it's really that these things are very much interlinked. And if you were to open up someone's brain and ask them what's the difference between these things, you probably find that they don't really quite know. That might be one way you could approach that problem. So here I'm trying to, I guess, contextualize and show what I can do with linear regression rather than what is linear regression. Whether or not my answer just there was the best is completely questionable. Obviously, I haven't prepared for this. I probably won't prep for an interview, but you get the idea.
Yeah, you can. I do think it was an important point that you made first, that it may be worth a follow-up question when I say what is linear regression to ask. Do you want a mathematical thing, or would you like a story of how I used it? And I also think if you're using star, you can use star explicitly. And by that, I mean, I was in a situation where there was a simulation we had, and experts knew which variables were important, but my task was to decide at what levels we should be using these. And so the action I took was, there's this area called design of experiments. So I went out and found the books about using this method to get an optimal set of simulation tests to run. And as a result, we were able to identify the most important variables over a subset in which interactions might be important. So that instead of running millions of things, we ran thousands and got results which later on we confirmed were appropriate. And so that way I've given myself kind of the outline of STAR. And if I say the situation, the task, the action, the result, it can help bring everything together.
It's
and true. For me, that was the case from my early career. But you can do the same thing. That the situation I was in was I was doing some group work. What I will say there is, some of the best advice I was given about interviews is the person interviewing you is looking for two things. Can you solve their problem? Will you be a good cultural fit?
Yes.
So if you come in to say, yeah, I was in this group work, my other group members, boy, they were worthless. and you talk about other people that way, I'm going to be quite put off, and I don't care. Well, I care a little bit if you're a real superstar, but you'd have to be a superstar, because if you're dissing your group mates in front of me, you're going to diss your teammates and you're going to diss me. And so you've just lost a lot of points. It's very different from, we were in the middle of lockdown. Some of my group members weren't handling it as well. So we prioritized the work, so that, because I had a little bit more capacity. And so, I played to their strengths and played to my strengths is a much better answer than, boy, it's a good thing I was there because I saved the project. It's not, it doesn't sound as good as you think it does to say something like that.
But I do like the signposting, because it helps in two ways. Like, it helps the other person understand it, and also prompts you to not forget. Because like that story I just made up before, where I was trying to think about it on the fly, I didn't set the situation. I kind of just got little bits of it out. And, hopefully I talked well enough to kind of hoodwink you to some degree. But I mean, honestly speaking, I was only about halfway through when I found a good example. And so like the STAR method does kind of discipline you to make it into an actual narrative that follows a reasonable structure to, not omit stuff that matters, that will help the other person get it. And also, to your second point, I was going to say, I think there's really interesting ways to like say negative things about peers and companies, that you've worked with in the past. There's because you're allowed to, but you have to do it in a certain way. There's certain rules.
Yeah.
If you say that they were, you didn't always get on perfectly well, but you definitely tried your best. You say like things to say like, I accept that they're nice enough people, and I wish them well. That kind of shows that you really didn't like them, but you're saying it in a way where you're clearly holding back and you're capable of restraint. And then if you focus on the facts, they might be like, oh, wow, you're a saint. I can't believe you're not just openly like bad-mouthing these people. You must know a lot about loyalty, because if the facts speak to your favor. Obviously, if the only problem is that, one time they accidentally ate your lunch and you now hold a grudge.
I hate them. I a lot of these things about, tell me about a time you dealt with conflict. That it always has to end with, and then we understood each other.
Oh yeah.
Right. Or we came to some conclusion where, we agreed to disagree, or, and then the facts came out. We made a bet, that I thought, we did an A/B test to see who was right and who was wrong. As you say, that there are ways and ways to say you get along with people or you don't, or you disagree with people, or philosophically, whether or not you think XGBoost is the best algorithm ever. And then I come along saying, have you tried linear regression? Like, really? Or logistic regression? Have you tried those first? What are you doing? By the way, where are you getting your data? Like, there's ways and ways to approach that.
It's definitely way. Yeah, I definitely agree with that. I think you're right though, that the kind of end of the story always has to end on a kind of happy note. It's kind of like 80s TV back when, I'm talking about those it's like, I'm once again going to TV references, and I swear it's always TV references. I try to use vanilla as when it comes to work conversations, but
my TV is different from yours.
That's true,
right?
Think about the Wonder Years, where every single episode had to end with a life lesson or something. You kind of want to end with that. You want to end with either we all made up and we all lived happily ever after, or I realized I was kind of not being the best, and I've since tried to improve. And those stories of redemption as well are quite powerful. I think it shows it's not even a play. It shows a certain level of humility that you're able to actually learn from experience and be open about where you've messed up.
Right. That I think is the more important one. And then I learned, and it could be, and then I learned something technical, or I learned something about stakeholder management, or I learned about, just because I have the best mousetrap doesn't mean I win. Or, I learned the importance of storytelling. I learned being able to show that you learned from a real situation is a different skill than, and then I Googled it and I took the Udemy course and I learned.
100%. I think, I think when I feel bad sometimes. I think for some people who work very, very technical jobs and they're very technically minded, because I think it can put you in a position where you get kind of shunted off into a certain like bucket or a certain part of an organization, and you haven't really seen the sun long enough, like not literally, but you haven't seen outside the greener pastures that are available to you. And if you don't know the game of a job interview, you don't. I can give an example, actually, a perfect example of a person who didn't understand the kind of the courting dance that is a job interview, where this is a group interview for one of those entry-level jobs that no one's particularly excited about. It was like a call center job or something I was doing 20 years ago. And we all came in as a group interview. Not everyone's going to get the job. So they ask questions like, introduce yourself and tell everyone why you want to work here. And as one person said, oh, well, I was working at Pizza Hut. I don't have that job anymore. So now I'm trying to work here. I'm like, oh, well, why do you want to work here? And he's like, and he was kind of flustered, like, I was working at Pizza Hut. I don't have the job anymore. And now I'm trying to get a job. I was like, obviously I'm just doing this because I have to. And it was quite confused, and like he didn't get the job, but it's kind of not really fair because no one really told him that he has to kind of say like a whole bunch of white lies to kind of get in the door. And the same goes for data scientists. Like, it's not just like the question they ask, you have to think about what they're looking for. And if you don't think about what they're looking for and just answer the questions, your opportunities will be like way lower than what they should be.
But I do think, going back to, is what they say they want actually what they want? I think if you go in with the strength of, this is what I can do, and I think you want that, I think you need that. And if they have their laundry list of 20 things and you can only do 3 or 4, say like, I really love those 3 or 4. These are the 3 or 4 that have really drawn me to the role. Because I often think that if they have the laundry list of 20 things, they don't know what they want. Or they want a team that amongst them will have those 20 things. But or they are going to work you to the bone. And when you don't do magic, it's not going to work. That they want you to be the data engineer and the full stack developer and the statistician doing cutting edge. Like, I don't. Unless you're at Facebook or Google, I don't think you're really gonna, or at a university, I don't think you're really gonna do cutting edge machine learning or computing. Well, computing maybe at some of the hardware manufacturers, but I don't see any of the major banks really investing in high-end AI ML.
Somehow my phone volume is just cut out. Oh, there we go. Back.
Welcome back.
Yeah, it was odd. I think you're right. They always seem to act like they want all that crazy stuff. But I think it's like, if you're your 5-year-old self and you say like, write the qualities of the best friend you could ever have, you'd basically want them to have every possible imaginable good trait plus a few that don't exist. That's pretty much what we're getting at the moment in the industry. I have seen though, especially because there's 2 situations. There's one which is like a typical company where they try to hire that, they get no one that's that good, or maybe 1 or 2 people, and they just don't accept. And then they're kind of stuck with someone that they think isn't good enough, and they may not learn the lesson that person wasn't the person they needed anyway, because they just didn't get that person. But then I've seen on the other side companies that are much more successful, and they sell people these jobs, but they don't quite know how to temper people's expectations, because they basically, it's as if you're going to be going in there doing the most crazy cutting edge advanced machine learning ever, and then you're doing data cleaning all day and answering basic questions, and people get frustrated and then they leave. So I see it as like kind of mutually harmful. Like, no one's really winning in this situation. Whereas if they made it based on like this, here's a description of the actual job as it will look like day to day, you'll get people who are more interested. And then if you test them based on their ability to do that job, you might find people who are actually good at it.
Yeah, the fact that it's mutual is something that I think a lot of people forget. That when someone's looking to hire someone, it's not out of the goodness of their heart. It's that they need some work done.
Yeah.
And as a person being interviewed, you do have some power, because the business does need to get this work done. And be able to push back, to be able to question, to be able to focus on the things you want to focus on. You know, when it says that you're going to be using AI ML and you say, oh yeah, well, which algorithms are you currently using? And they're like, no, you'd be the first one. It's like, this is telling you a lot more about the job and the role.
Oh, this is actually a really, really big one. Something I'm a very strong believer in. I do it anyway, but for data science jobs, product management jobs as well, it probably counts just as much, but in a very different way. The interview is a reciprocal process, but
Yes.
for data science, it's probably more than reciprocal. Like I say that they're interviewing for you more than you're interviewing for them. And it's definitely the way you should look at it if you're a data analyst. So in that, you know, a lot of companies, like if you were to just take a random sample of like analytics jobs from the world, I would say that most of them would be unsuitable. Most of them would be bad, rather than most of them actually being good. If you took a random sample, obviously you're not applying for jobs randomly. You're probably looking for reasonable companies that have a reasonable reputation. But you know, you'd have every reason. Like if there was some company that you've heard of, but you've never seen the analytics before, you've never seen the inside of the actual shop. So let's just say it's like Kellogg's, for example, just making one up as an example. You know, I'd be very cautious. I want to make sure that they've really invested in the right kind of infrastructure, so that I know I'm not holding all that stuff up on my own or with the rest of the analysts. Like it happens very often that you have really bad systems that aren't maintained. They need IT investment before they need analytics investment. And I'd be asking questions about that. Then there's just the actual work. Like, will I be, you know, sitting around building dashboards that no one looks at all day, you know, as part of an initiative to get people to start using analytics, but they never will. And there's no way that we could ever automate decisions away or have data analysts like lead the charge or anything. Then I'd also be disinterested, like, or at least it'd be harder to get my attention.
Yeah, as a consultant, the type of job I'd prefer to get is, we're thinking of doing this. Could you give us an audit of sorts? Could you give us your opinion as to where we should go and where we should start? As opposed to, now we want to use big data in the cloud.
They say big data
with the data science.
Yeah.
Like, it's like, what does any of that mean? If it gives you answers you're not ready for, are you going to be ready to change your opinions?
Yeah.
Because especially with some of the, as you were mentioning, the trade-offs between interpretability and accuracy, for instance, versus how do you know when you've overtrained? And how do you know when you've overtrained is one of these, the answer is so easy, except for when it's not, because you have that graph of all the data points and it, you know, is going through all the data points, you know, just perfectly, as opposed to the parabola, which fits pretty good. And it's like, okay, show me that in 20 dimensions. And suddenly, suddenly people struggle a bit. They just say, well, my mean squared error is lower. I'm like, yes, if you remember this, the mean squared error on that squiggly line is also lower than if you use the parabola. So it's one of these questions that if I were interviewing, I'd ask people about overfitting and how do they know you haven't overfit? Because there's no good answer. You can Google it if you'd like, and you can make that picture, but then I'm going to follow up with, now show it to me in 8 dimensions. And now what?
Yeah, that's a really good one. It's actually as well, because the multidimensionality of it is a super big challenge. Yeah, I mean, that's one of those ones where I probably wouldn't have a good answer for you. I could definitely talk about the parabola, but then multiple dimensions, I don't know.
Right,
and,
but that's the thing, is I know there's not really a single answer. So I want to see what you say and what, because eventually I want you to get to the point of the lowest mean squared error might not be the best, because I don't know if I've overfit, because I can always drive it down by adding more parameters, but you know, is it statistical and is it useful? And you know, if I can get from mean squared error of 0.1 to 0.01, how much of an uplift is that going to mean to my business? Are they about the same? Are there other sources of uncertainty? Because, you know, all this model is doing is saying who to call, but who actually answers the phone is a bigger driver than the model. Or, you know, just because they click on it doesn't mean they buy something, and just because they buy something doesn't mean they buy enough, or they wouldn't have bought it anyway, or In credit risk, this happens because there's the credit risk of the individual, but then there's a lot of regulations on top of it. And sometimes the regulations in terms of, okay, they may be able to afford the loan on paper, but the regulator just changed that you need to assume that the interest rates has gone up by 3%. Can they still afford it? Well, sometimes that can be a stronger factor than what their credit score is.
Yeah, it's very true. Yeah, and I think that's the kind of area of analytics I find the most edifying. I find the most interesting when you're looking at the actual you're interpreting what the model is telling you, and you're thinking about what's the impact of this, or you take the overfitting example. That's it's fascinating. You might see that your total mean squared error is going down and eventually starts to tick up, but where are you failing to predict well? It might be that, yeah, for the most part, for your best case, for your happy path, the model is working really well with these hyperparameters, but maybe this variable here, when you have this area of sparse data coverage, you're going to the default value every time, and maybe that's wrong every time, even though you're 99% accurate. That 1% where you're off, you're embarrassingly, illegally wrong.
Yeah.
Which is the kind of situation you're talking about, right?
Yeah. And with the internet, they'll tell you about it. That if you're making advertisements on Facebook and African Americans are more likely to see bail bonds as something you might be interested in than white people, it's I'm not sure you want that, right? It's with a lot of the press out there, and it only takes one person to be like, hey, look, like the chatbot, the Microsoft chatbot that was asked if the chatbot thought genocide was a good idea, and said yes, absolutely. you just need that once and someone posts it, and now what?
Yeah, absolutely. No, so much, and that's where things get interesting and exciting. For me, that's the fun part of analytics. It's not just optimization problem, for some linear algebra at it. That's definitely not my strength, not my interest or motivation. So maybe to wrap up, I've kind of gone through our kind of respective histories and then job applications and stuff like this. Maybe for any viewers out there, I imagine there's a lot of people out there just looking for career advice. What advice would you give to yourself or to someone, let's say, who are at they're in their first year or just about to start their first year in analytics?
Yeah, so I'd say certainly the STAR method for interviews makes sense. And again, even if you do find yourself the situation I was in, the task I was given, the action I took, the result was. Anyone listening to you will quickly be like, okay, you're using the STAR method. You're using the STAR method very precisely, but it's a place to start. The second one would be to make it personal. And if you don't have experience, you have more experience than you think. Talk about your homework assignments, talk about your group assignments, talk about, a Kaggle problem you had, or you wanted to see if you could get the data. If you are looking at COVID dashboards, if you're looking at whatever, right? Just come up with stories that you can tell. Give them a nice way to end that, maybe not, and then we all lived happily ever after, and that led me to, and if the conclusion, I'm trying to avoid some words here because I know the internet. If the happy conclusion is that it brought you to the interview, then that's a good thing to end on, because you're saying, I'm grateful that I'm here talking to you now. I'm grateful that this opportunity has come up. I'm excited about this opportunity. There are several things about that behavioral aspect that I want to be doing this. I want this job. I want I want to learn on the job, especially as someone junior. Jahan and I, we've both learned on the job.
Yeah, absolutely. And I think people respond really well to people who are genuinely excited and bring a bit of excitement and certain aspirational charm that everyone kind of likes to see. It's always kind of nice to see those people that are you can always tell when someone's green. They don't know that much, but they seem very excited. And it's often nicer to talk to that person than someone who's been doing it for a while, but it's kind of putting you to sleep. Not like everyone has been doing it for a while. We'll do that, but you know what I'm talking about. There's something nice about that. I'd say to add to your points, because I totally agree, 100% agree. I think the only other thing I'd say is echoing the sentiment of you've got more experience than you think. I think there's a laundry list out there in data science that would probably take several lifetimes to finish, to actually get through. And the idea that you need to, it's almost criminal that people are telling everyone that they need to know all this stuff. I say just know the basics, and then have a couple of areas, 1 or 2 areas that you're really passionate about, that you have become quite good at. So like obviously know your SQL and your Excel and stuff like that, know your basic statistics and things like that. But then afterwards, maybe you're the person that's really good at predictive models, or maybe you're really, really good at recommendation systems, or maybe you've got a little bit of a flair for data visualization.
Mm-hmm.
Maybe you understand the business really well. Don't be ashamed of not knowing all the things, because in a team you don't need every single person to be an absolute expert in gradient descent. Like it's redundant, and to be honest, some people, even practitioners in the field, will probably tell you it's overkill.
If I'll say, it's been a while since I've used gradient descent from scratch, as opposed to calling some optimization code, which might not actually be using gradient descent actually. But, yeah,
whatever it's doing, if it's working, we're usually happy. So yeah.
But yeah, and because if you can turn the interview to a discussion about yourself, now you're the expert.
Mm-hmm.
And now you're talking about why you should be hired for this role. Because especially if you're graduating, well, what's the difference between you and any of your fellow graduating class? Maybe your grades are higher, maybe some of your grades are higher, but otherwise, saying you have the master's degree that the other 50 people in your class do, that's I would say necessary but not sufficient, but I don't think it's even that strong. That might be correlated to you getting a good job, but it's certainly not causal. And the more you can differentiate yourself and make the conversation, the conversation about you, which you're an expert in, the better off you'll be. The final thing is, don't be afraid to fail an interview. And if you are failing an interview, be ready to use your network in an altruistic manner. And by that, I mean, if I'm in an interview and it's not going so well, because it sounds like they need more of a product manager, that I might say, look, this isn't right for me. Let me introduce you to Jahan, so that he might be able to help you in a way that I can't.
Yeah. And that's a good idea. People always respond to that. Things will come your way. I've networked my way into a job before, and it was just about showing up, doing work, being reliable, and making an effort for people, and people make an effort for you back. I didn't do the networking with that in mind. It just kind of happened.
I've had that both ways, both in the sense that I've recommended someone else for the job and I've been recommended by others. So don't be afraid to go into an interview, and when you know it's not right, to leave gracefully, rather than don't keep going with the interview when you're like, oh, this isn't going to work.
I usually will get through it, but that's those words aren't unwise. I think that's reasonable. All right, well, we might wrap it up there. So thanks for everyone who watched the whole thing. If you did, comment spaghetti in the comments, then we'll know.
I don't know spaghetti.
Yeah, just spaghetti. The probability of you doing that is infinitesimally low. So we'll know that you watched the whole thing, or that you skipped to the end and watched the very last little fragment. But we'll assume that you just watched the whole thing, just to be a little bit on the optimistic side. Any questions you have?
It may be that there's a spaghetti emote. If there is, I want to see it. I don't think there is, but if there is, I want to see it.
Really?
I'm not really into the Twitch emote, like poggers or or monkas or kappa. What are some of the other ones? Some of the other little things.
I'm not even across Twitch enough to know that. You're now you're the young in between us now.
That's frightening. But yeah, thanks everyone.
Yeah.
And we will be back in a fortnight.
Yeah,
Is that the plan?
1 to 3 weeks might be. That's
3 weeks? Yeah, because the 11th is a holiday.
Mm,
Here it's Remembrance Day or Veterans Day in the US.
cool. But
We
yes.
celebrate slightly different things, but that's fine.
But yes. And yeah, on that note, we need to end on our with our little meme to try and build the channel. So we'll say, and we'll see you in 3 weeks. How's that? Yeah, there we go.
That sounds good, but we're still very much YOLOing this. If there's anything else you would like us to discuss, because we are still in a very YOLO framework, please leave a comment down below or send us a message if you know us personally.
Yes, by all means. All right.
All right. Good night.
I think because we're still live, right? I can almost